So we're now recording. And yeah, thanks for that, Joe. For people just joining us, we're just going through our community info. PyData SLC, they have a meetup here. SLC Devs is the language agnostic one. We have some websites that definitely need updating. I think they're like 2 years out of date now. Yeah, this is like the chef's dilemma. If you ever know a really good chef, you'll know that they usually cook microwave food at home. So definitely need to update those. Sponsors, Pythonistas like you, thank you so much for your online donations. X-Mission, University of Utah is our venue. Typically, when there's not, a zootonic plague. X-Mission has been great about funding our pizza since for 3 years, I think. It's for a long time, consistently. Thanks for them. Tech Systems has sponsored raffle prizes. Kate, do you want to tell people about Tech Systems, or should I give the spiel?
Sorry, can you hear me okay?
Yeah.
Okay, awesome. Yeah, I am in the car today. Jason and I are actually taking a little drive, and so I was like, but I can't miss Python. But yeah, so hi guys, I'm Kate. As Farrah said, I'm with Tech Systems. We're the nation's leading IT services and IT staffing provider. We've got locations in every single state and quite a few countries as well. And what I've been kind of talking about lately, and I know I've mentioned this on a lot of the Python meetups, is kind of the cool thing right now that COVID gave us is so many companies are now saying, hey, 100% remote is totally okay. So that means if you are looking for work, I don't just have to look in Utah these days. I can look all over the place. So yeah, we have lots of fun stuff out there. I don't have my computer in front of me to do the cool little search and say like how many Python positions I see in the system, but I'm sure there's still quite a few. So anyway, thanks first.
Yeah, excellent. Thank you, Kate. And I always bring up Tech Systems because they're really good about narrowing down the right fit for both candidates and for the job. So if you're not into doing mobile development, Tech Systems won't ask you about Android and iOS development. And that's what's awesome.
Unless you really want to do that.
Exactly. How to sponsor? New sponsors are always appreciated. Just hit us up on Meetup. Our expenses and sponsorship have been updated on SLCPython/money, and I think I got the last ones as well in there in preparation for a meeting with Joe and Dylan I got to have before the end of the year. And then, yeah, just send a message. We'll take it from there. And yeah, so the next thing we usually do is we introduce our new members. So if you've never been to this meetup, go ahead and raise your hand. There should be a little way to do that, little icon somewhere. I'm trying to see if I can see the attendee panel for some reason. Oh, here it is. I see it now. Oh, okay. So we have got one hand raised. Anyone else who's new to the group, you get to introduce yourself. Well, and I'll give an example. So we always do something non-codey. So name and occupation and most festive thing you do in December. So I'm Ferris. I'm a backend developer at Invite, and the most festive thing I do in December is probably I have this inflatable penguin that I set up on my front yard, and it's really cute. So that's what I do every December. So Lynn, you raised your hand. Would you like to introduce yourself?
Yeah, hey, my name's Lynn. I'm actually mostly a Java developer, but Kate actually sent me here because I was interested in like AI stuff. So thanks, Kate. Most festive thing that I do is, it's kind of weird, but I like to, on the winter solstice, I like to go out and have a bonfire in the mountains with some of my friends and family. And so it's kind of fun.
That's awesome. That reminds me of, there's a European a concert that they do at solstice every year, the NPR broadcast, and I've always liked solstice celebrations, like just knowing, oh, the days are going to get like longer now. Oh, that's really cool, Lynn. Welcome to the group.
Thank you.
Drew, would you like to introduce yourself?
Yeah, sorry, it took me a little bit to click around. My name is Drew. I'm actually a student at Utah Valley University. I'm interning at a company called Halos. I already do natural language processing and have had some exposure to Python. I honestly kind of just Googled Python groups about an hour before you guys got to meet up, and I found the link on Meetup, so I just signed up and hopped on. So I just found out about this about an hour, 4:45 or so. So one of the most festive things I like to do, I went to Luminaria this last week. It's the light show in Thanksgiving Point, and I've always liked that. They do an awesome job. It's really cool Christmas time to do.
Sweet. Well, welcome to the group, Drew. I guess you're our newest member, huh?
Sweet.
And then Akshit, and sorry if I pronounced your name wrong.
Yep, that's correct. Can you hear me?
Yes, I can, loud and clear.
Yep. My name is Akshit Agarwal, and I'm currently working in Clearwater Analytics in Boise, Idaho. And my job is to automate business process with Python, SQL, and like using all the cool libraries in Python to automate all the boring process in the company and save time. And the main thing that brought me to this group was I'm trying to improve my knowledge on machine learning and AI. I have done some toy problems and some NLP projects, but I want to learn more and get better at it. So I just wanted to. I'm just here to learn for the most part. And
welcome to the group. Oh, sorry. Yeah, and what's something festive that you do in December?
I usually go back to my family in Phoenix, and then we decorate the Christmas tree, and hence have some good food and wine by the fire.
So make a Zoom Christmas tree, perhaps this year is in order.
Yep.
I don't know. Yeah.
The
wine should still be a thing, though. I mean, maybe set up like another laptop to have like the fake fireplace, perhaps.
Yep.
Well, excellent. Welcome to the group.
Thank you.
Anybody else who's new to the group, care to introduce yourself? Go ahead and just raise your hand. Oh, I got one from Shanker.
Hi, this is Shankar. Can you hear me?
Shankar. Yes.
Yeah, I'm new here, and I hear about this from my colleague. And I'm an electrical engineer, specializing in signal processing. I want to learn Python and use more cool stuff. By the way, I work for Heretics, and I'm a vice chair of IEEE, so I'm just trying to see how we can collaborate with IEEE and this Python group, and looking forward to involve in this group and get more ideas from the smart people.
Well, welcome to the group. I think something I really like about this group is I tend to be the dumbest one in the room, and I really appreciate that. So it's really awesome being surrounded by really smart people. I always feel like I'm learning something new, even from Python beginners. They're usually coming from a background of, oh yeah, I'm a Python beginner, but I also did 3 or 4 PhDs in physics or whatever. So it's always awesome to meet people who are using Python to do cool things. So you're in the right place.
Agreed.
What's something that you do for in December, something festive, the most festive thing?
I just hang around with my family and friends. Nothing much, no very aggressive plan.
Might I recommend watching Die Hard? Just saying.
Yeah,
the best Christmas
I
movie
love
ever.
watching
There you go. There you go.
Yeah, thank you.
Thank you for saying that. That's my Christmas Eve tradition. Die Hard, best Christmas movie ever.
No, I totally agree. We started that as a tradition in my house a few years ago, and it's definitely a great, even to have in the background. Yeah, awesome.
That's like my brother's favorite Christmas movie. I have never seen it. I vowed that this year I was going to watch it.
Here you go. I think some of the apps now I think with Disney Plus, you can watch something at the same time as somebody else. Like you can sync it up and have a remote watch party.
I think
so,
I can hang out with my brother and watch it. I love it.
Does Netflix do that?
Yeah, I think Netflix set up a feature where you can like synchronize it.
Nice.
Yeah.
All right. I'm planning it now.
Yeah, do it.
Yeah, that would be cool.
Now I feel like we should do this for our group and just watch Hackers, that 1999 movie.
Oh my gosh. You have no idea. My husband brings up that movie probably at least once a week. Like, he just thinks it's funny to be like, so have you seen Hackers? And I'm like, yes. We've both watched it multiple times. And the other day, like, he comes into the room and he's like, hey, close your eyes. I have a surprise for you. I'm like, okay. He comes over and puts the DVD from Hackers in my hand. So you have no idea, like, what a role that plays. So yes, we should all watch Hackers as a group.
Maybe this should be our soiree. We should get real creative with the soiree. There should be some food aspect.
I love it. Let's do it.
And then like a movie aspect at the end where we all sync up and watch a movie if we, for those who want to.
Is the Hacker in Netflix?
I don't know what it's on, actually. I think part of the challenge is...
it's just like free.
Yeah.
Like
okay.
A YouTube.
I think if you like SSH into the right place, you should be able to download... I'm just kidding. You have to be a hacker to watch Hackers.
You telnet it. It's all ASCII art.
Yep. Well, I love that tangent. On that note, perhaps let's talk about who's hiring. Let me actually share our agenda again. So everybody knows you can talk to Kate. She's awesome. Feel free to. You're on the Slack as well, Kate, right? So feel free to ping her via that.
I am, yeah. Awesome.
My company where I work in Vitae, they are still hiring for senior backend roles. This one, I don't know if this was added just now, so I'm going to remove it unless because I copied and pasted. Sorry about that. Okay.
Yeah, I think they hired somebody. You can take it off.
Okay. Verdigris? Dylan?
Yeah. Verdigris is still hiring. We are looking specifically for a senior ML infrastructure engineer. So somebody who's really good at Kubernetes, who likes data and wants to help get those, and likes DevOps and kind of bringing those together into this ML ops field. That's really exciting. There's like a lot of new tools and things going into it. And so looking for somebody who really knows their stuff for this role. And also probably we'll have some other hires coming up in Q1. So that'll be exciting as well. I'll be able to announce it next time.
Excellent. Let's see here. Recursion. Anybody from Recursion able to speak for this role?
Yep. I'm going to put it up there.
Oh, thanks.
So Recursion is on a massive hiring spree right now. We have more than a few data science roles open. Oh yeah. A couple of machine learning scientist roles, including one that specializes in computer vision. We have another one for learning chemistry structures. So two fairly different roles that fall under that umbrella. And then we have a senior software engineer role open and also a cloud infrastructure engineer role that's going to be on my team. So similar to what Dylan talked about, back-end infrastructure, Kubernetes, DevOps tooling. We're looking for people who collaborate really well between teams because we end up being kind of the glue between all the other groups of the company. It's actually really fun. So Recursion is also a really awesome place to work. We have a ton of science, lab, automation, business, and recruiting roles also open. So if you know anyone who's looking in those fields too, please send them our way.
Awesome. And my old lead, Eric, actually works there now, so it's kind of funny.
Erichurst, yes, he is awesome.
Yes.
We're happy to have him.
Yeah, he's great. Also,
quick question, Isla.
Yes. Hi, Kate.
Okay. Super good to see you, by the way. Do you know if they work with outside vendors at all? Because one of my account managers actually told me today that he was really hoping to try and get into Recursion.
Outside vendors, you mean like outside recruiters?
Like tech systems. Like, do they work with like outside companies like that, or do they just solely rely on the internal recruiters?
No, we do work with outside recruiters as well.
Okay, I am totally going to be reaching out to you after this, so I don't take any more time.
Okay, sounds good.
Thank you.
Awesome. It looks like Branded Entertainment Network was just added.
Yeah, I just added that. So actually, Tyler Folkman, who heads up data science over at Branded Entertainment Networks, they do like influencer marketing, something or other. But they're hiring for somebody savvy with machine learning and engineering. Hit me up, or if you know Tyler Folkman, hit him up. Tyler's also going to be speaking at the next Salt Lake City Python on January 6th. So you can also hit him up in January, or hit me up before.
Nice. All right, anybody else can speak to any, doesn't even have to be local, just as long as it's Python related. Go once, go twice. All right, and then who's looking? Looks like Todd is already on top of it. Todd, would you like to introduce yourself?
Sure. I'm Todd McDaniel. Like it says there, I was a system administrator for 10 plus years. I transitioned from higher ed to the private sector, and now I'm back in the hunt for another position. And I've added a lot of AWS with Lambdas and various other APIs. And I'm looking for something new. Thanks.
Awesome. Thank you, Todd. And it looks like D. Ivanov?
Yeah, hi, my name is Dimitry. I have been with this meetup group since about 2015 or so. And I was at University of Utah. So anyways, I would like to switch from being a postdoc in physics to like doing data analysis for the private sector. And I was wondering if anyone is looking for someone who is like really good at code debugging and building models and fitting data into stuff. And writing code in C++ and Python, that sort of stuff. So at the beginner level, not at the senior level, obviously, because I have not really worked in the industry yet much, but I would like to learn.
Awesome. Thank you. I'm trying to format this the right way, and it's not playing nice, but that's okay. Anybody else who's looking? Go once, go twice. All right, and a couple more notes. You can always go to the PyCon online job fair. I don't think they've had any new postings lately, but I mean, they were updating it, so it is still a fairly dynamic resource. The more dynamic resource is Python Jobs HQ. I'm not like nobody pays me to mention these. These are just resources that I found, and they also give a good sense of what is available. And yeah, this is probably the most busy I've seen it in Q4 ever. So kind of interesting. I've never seen a Q4 with so much hiring going on, but you know, it's a weird year. So cool. Python 3.9, let's talk about community news. You can always look at PyCon 2020 talks online. I haven't heard any news about PyCon 2021. I'm assuming that just no real decisions have been made yet, but I'm assuming it'll be online, obviously. Probably just one more year of that. But yeah,
Videos of the 2020 videos are really fun to watch. They have a whole big page, and like there's some really good information in there if you just like throw it on instead of, you know, watching that TV show on Netflix. You just throw on some of these. They're like, they're good.
Yeah. And then Iwa, she's awesome. She's been heading up the PyCons for almost 10 years. Holy moly. So she's had a lot on her shoulders this year. So yeah, if you ever want to Twitter bomb somebody with like something really nice, just go ahead and Twitter bomb her and say thanks for like putting together PyCon. But anyway, yeah, it's the good kind of Twitter bomb. Let's see. Well, oh, this is just, I was thinking maybe we could play with Docker 3.9, but we don't have to do this. This is how you could, though, if you want to play with 3.9 without installing it locally. And then this is a lot less irrelevant because Python 3.9 is fairly available. I think you can brew install it now. So if you're on a Mac, it's more available. If you're on Debian or Ubuntu or some kind of Linux distro like that, then you'll probably have to update your source. But yeah, 3.9 is out in the world. We have a cool logo that Dylan came up with that is approved by the Python Software Foundation. It is this. Here is our GitHub repo. Feel free to make pull requests and what have you on it, but this is our logo. Oh, and Dylan has our face mask, like front and center. So we also sell face masks. Boom, and where is that? Ah, here we go. And we have neck gaiters as well. So if you're looking to get out in the world in style, we got you covered, literally. Yeah. Let's see, where were we? Oh, okay, there's the Data Heretics podcast with Joe Reese. You want to get into that a little bit? And maybe we should move this up to the community. I'm going to do that, but you want to give a brief intro?
Yeah, well, that's actually tomorrow, tomorrow night. So it's me and a bunch of 3 other people we met on LinkedIn of all places. So we just do this LinkedIn Live. There's get a pretty big audience. I think we have like 400 or 500 people attending. So we'll just be riffing on data and dorking around. So really doing a good job at selling this. So anyway, yeah, show up.
Awesome. Let's see, data engineering with Prefect.
Yeah, that already happened.
Okay. Oh, yeah, that's. And then Reinvent, is that still going?
That just happened like yesterday. It's gonna be going on for a few weeks. Yeah.
Oh, so it's ongoing right now.
Yeah.
Okay, excellent.
Free to sign up. Highly recommended.
Yeah, I mean, how much is it normally? Isn't it a couple thousand or something ridiculous? Yeah. So I remember that Reinvent was just the conference that was super pricey. That would be the one, if you had one conference that your company would cover, you would definitely ask them to do that one. I remember that. So, okay, that's cool. It's free. Awesome. So if you want to get locked into Amazon, I mean, if you want to use, I'm just kidding. Yeah, AWS Reinvent.
There's some really cool talks. Like if you go back and watch some of the keynotes, Andy Jassy brought out several new cool tools yesterday, and there'll be a few more keynotes that should be pretty good. And there's one next week about ML.
Awesome. Okay. And that's pretty much what we have for like the non-code side of the agenda. Typically we'll do like a beginning Python something here, but I also want to be cognizant of our speaker's time since he's on East Coast. So I'm going to actually go ahead and pass it over to Danny. One more time though, if you want a link to the Etherpad, it's right on our meetup page as a comment, and feel free to add notes as a group. So Danny, are you ready to go?
Yes, sir.
All right, you can go ahead and take the share from me whenever you want.
Thanks, Faris. So before I do that, just as a quick introduction, my name is Danny Leybzon. I'm a senior field engineer at Imply. That means that I show up at meetups and conferences like this and bore you by trying to sell a product. No, just kidding. So I'm here to talk about something that you can do with a number of different tools, and I'm going to explain some advantages and disadvantages of those different tools. I'm not really here trying to like hawk my wares or anything like that. This is just a really interesting topic to me that I spent a lot of time learning about, that I'm very excited to share my learnings with the community. So machine learning monitoring is a really important concept. If y'all were around a year ago, I talked about productionizing machine learning models at a number of meetups, both in Utah and around the United States and Canada. But one thing that I felt like was really missing from my presentation at the time was that I was just kind of like, okay, and then it's in production and you're good to go. And like, that's the end of it. So I wanted to like come back and give a fuller story, which is why I'm here to talk about monitoring machine learning models after they're in production. Because this is the SLCPython meetup, I really want to try to emphasize the Python components of what I'm going to be talking about. A good deal of machine learning obviously happens in Python, especially at the dev stage. In production, it tends to be a little bit more mixed, and the tools that people use for monitoring run the gambit all the way from Python to like C++ or custom-built applications. But I'll get into that during the presentation itself. So let's start with a screen share. There we go. So with a little bit of tongue-in-cheek, I'm referring to monitoring the machine learning models as the final frontier, because I think, to me at least, it's the last step in the ML model deployment process. You know, after you've productionized and deployed the model, what you need to do is monitor it. And I'm going to be talking about monitoring by answering 3 particular questions that I think are the most salient for machine learning engineers, software engineers, data scientists, the management or executives of people overseeing those types of people, and in general, just people that are interested in these types of topics. So I'm going to be talking about what is machine learning monitoring. I'm going to talk about why you need to do ML monitoring, and then I'm going to talk about how to do ML monitoring, both from a theoretical perspective, so just looking at kind of the state of the industry, and then a practical perspective, which is where, you know, the kind of Vendy salesperson-y thing is going to come in. I'm going to walk through like training a machine learning model in Python, and then pseudo, you know, fake deploying it and monitoring it with Implied, the company that I work for. So if you're absolutely not interested in seeing a product demo, I'll be very explicit about the part where I start talking about proprietary software. So let's start off by answering the question around what. What does it mean to monitor an ML model? And in order to answer that question, I want to give you kind of a high-level perspective of where all of these conversations are coming from. So 5 years ago, Google published this paper, Hidden Technical Debt in Machine Learning Systems. You know, kind of a boring name, a lot of words. What does it mean? This thing revolutionized the field. I mean, this basically jump-started the careers of the majority of machine learning engineers, all because of this simple visualization, all because Google managed to point out, you know, visually and very simply that the actual process of deploying a machine learning model, of having a machine learning model provide value for a business, there's a very tiny component of that that's the machine learning model itself. And the majority is all of this stuff that goes around the machine learning model. So, you know, configuration, data collection, extracting features from the data to train the model, and then when it's actually in production, monitoring the model. So as I mentioned earlier, you know, last year I was going around and I was giving this really high-level perspective on the machine learning workflow, which starts with exploring and preparing data, and then it gets into building and validating a model, and then finally deploying a model and monitoring it in production. But, you know, as every framework or model of the universe, this was a gross and disgusting oversimplification. So I'm here to dispel the myths that I propagated a year ago, and to enlighten you with this much more complicated, but therefore also more correct model of what it looks like to deploy a model. So both build and deploy a model, I should say. So you'll notice at the very top of this that there's this arrow that goes back, because even though I referred to monitoring as the final frontier, truly machine learning models don't ever stop being worked on, at least, you know, best case scenario. And the reason for that is that we can constantly seek ways to improve our models. If you think about major players in the machine learning games, companies like Netflix, like Google, like Facebook, they don't, you know, deploy and walk away. They're constantly redeveloping their models. They're paying these, you know, these research scientists millions of dollars every year in order to develop better models, which is only useful if they go back and redeploy new types of models. So the process starts with model building, right? where you have a code component, which is the training code, and you've got training data, which is processed by the code. Now, from the model building process, you pick a couple of candidate models, and then you evaluate those models, you experiment on those models. That's going to generate some metrics, some useful information. Maybe you're looking at the F1 score, or you're looking at accuracy, or you're looking at some kind of metrics about how your models are actually performing. Now, once you've selected a model based on its performance, you're going to productionize it, which is to say, turn it from a piece of code probably in Python, maybe, to a piece of code in C++ or in Java. But more fundamentally, you're going to refine your model so that it's ready to be deployed. You're going to go through the regular testing cycle like you would for any other piece of software, any other software application. And then finally, you're going to deploy it. And once you've deployed the model, the next step is to monitor it and to provide observability for it. And fundamentally, what this means is collecting metrics. And that's the biggest takeaway. If there's one takeaway from today's presentation, I want it to be this, that monitoring a machine learning model simply means collecting different types of metrics about it. Quick shout out, I stole this diagram shamelessly from this really great blog post from Martin Fowler called CD4ML. If you're a machine learning engineer, I think this is basically like required curricula. It's super useful in helping you understand what is it that you need to do in order to take a model from the sandbox, from where the data scientist is working on it, to production, where it's actually producing value for your company. So like I tried to emphasize, monitoring an ML model is fundamentally about creating and tracking metrics about the performance of a machine learning model in production. But what types of metrics? I've broken down the metrics into 3 categories. Some people skip out on this last category and only talk about the first 2, but I'm going to talk about all 3 of them. So the first category is metrics about data getting fed into the model, which is data monitoring. And this is one that's pretty easy to do, and a lot of people do it very intuitively because they already have observability and monitoring built into the infrastructure around their machine learning model. So if you think back to our previous diagram, we've got certain production data that's being sent into our deployed model. And we want to be able to observe that production data to make sure that there aren't major shifts in the data. And I'll talk about what types of shifts can occur, but that's one component of monitoring a machine learning model that I want you to think about. Another one is metrics about the predictions that are actually being made by the model, right? So the whole process of machine learning begins and ends with a machine learning model making some kind of prediction based on some incoming data. So we've already talked about collecting metrics on the incoming data. We also want to collect metrics on the predictions. And the types of metrics that can be produced on those predictions is actually really interesting. The most simple one is that we can look at the predictions themselves. We can see stuff like, is the, in the case of a regression, is the mean of the prediction changing? Alternatively, if you're doing a classification, you can say, is the most common category or is the distribution of categories changing over time? And the reason that you want to monitor changes in the predictions is because if there's a significant shift in the predictions, that indicates that there might be something going on in the real world, some change in real world processes that are changing the data being fed into the system, which might mean that the metrics that you originally generated in order to compare and evaluate your model against other models may no longer be the case. What I mean by this is if I've got a model that got 99% accuracy while I was training it, even 99% accuracy on the test set, once I've deployed it, if there's shifts in the real world processes that are actually, that are affecting the data that's being generated, if there's shifts in these real world processes, then we're going to see shifts in the predictions and also see shifts in the accuracy of the model itself. So all of this to say it can be useful to monitor the predictions themselves. Another component of prediction monitoring that I think is the most interesting and cutting edge stuff that's happening in the monitoring ML model world right now is the ability to monitor metrics around explainability. So explainability is, a whole nother Pandora's box, another can of worms into itself. But from a high level, it's this idea that machine learning models kind of seem like black boxes a lot of the time. We know the predictions that they make, but we don't necessarily know how they made those predictions. So there's a whole school of machine learning, a lot of practice that goes into understanding what causes a machine learning model to perform a certain way. This is another meetup presentation that I'm actually working on right now around explainability and understandability of a machine learning model. But being able to track the metrics around explainability can be really useful for helping to track changes in the real world processes that might cause changes in how your model is performing. Now, the last type of metrics that you might be able to gather and that you should monitor around how your model is performing is monitoring the system. And what I mean by this from a high level is understanding stuff like how are the servers that are actually running this machine learning model, how are they doing? Like, are they running low on CPU? Sorry, is their CPU being really constrained? Are they running low on memory? Are they starting to return results a lot slower? You know, if you've got a machine learning model in production, you might have an SLA associated with it. In the case backtracking to Netflix, you know, when I load up the Netflix page, the Netflix homepage, it comes up with a series of recommendations for me. But if the model that produces those recommendations takes too long to create the recommendations, then the page is going to load slower. I, as a user, am going to have a worse user experience. And as a result, I'm going to stop going to Netflix as much. I might even stop giving them my money, God forbid. So if that's the case, it's important to track and monitor how my machine learning model is doing in order to understand, is my model still performing? Is it still as fast as I want it to be? Because I have some kind of SLA, some kind of service level agreement, which I need to adhere to. So these are the three types of metrics that you probably want to collect around a machine learning model in production. And if you feel a little bit dissatisfied with this answer about what, if this seems a little bit vague or abstract to you, don't worry. This is exactly why we have the how portion, where we get into the down and dirty of, you know, what you can actually do to monitor an ML model. But before we get into the how, before we get into, you know, into the meat of what does it actually mean, how do we actually do this, I want to explain why. And I think on some level, there's like some intuitive understanding of why you should monitor an ML model. But fundamentally, in order to justify anything to a business, you need to come up with a really compelling case for it. And the basic answer to why you should monitor an ML model is simply that its performance can change over time. You know, traditionally with software applications, they were pretty static. There wasn't a lot of like input output happening. We could run pretty simple test cases against them and perform QA in a pretty controlled manner. But we've moved past the days of static code, and we've moved into the world where machine learning models as code are actually functioning super dynamically. And that dynamicity means that we need to be able to track, is my model still performing? Because that performance can degrade over time. And if that performance degrades over time, then we're not going to be able to provide as much value for the business as we had originally promised them. You know, if my 99% accuracy goes down to an 80% accuracy, this might mean billions of dollars in lost revenue, or a highly increased risk, or you know, a lot of other potential negative impacts for a business. So that's the like simple answer to why you should monitor an ML model. But fundamentally, I've broken down the why question to three components. One is differences between sandbox and production data. Two is shifts in processes that generate the data. And there can be these shifts that happen because of independent changes in the real world, but there can also be shifts that happen because of model affected changes in the real world. And finally, we can talk about externalities affecting the system. So let's talk about these one by one. So the most common thing that I see happening when I see people deploying machine learning models and getting inferior results from deployment versus what they saw when they were working in their sandbox environment is that there's a difference between the sandbox data and production data. And this can happen for a number of different reasons, right? People will bring in data that has you know, some specific attributes or variables that might not actually be available in the production data, right? Maybe there has some leading indicator that points to what the right prediction would be. The machine learning model overfits to that particular leading indicator, and then the end result of that overfitting is that because that leading indicator is not available in the production data, the model is hugely underperformant when given access to fewer data. So this is a really common problem, a shockingly common problem that I see a lot of the times for data scientists and machine learning engineers who see really good performance when they're testing the model, but then see far inferior performance when they've actually deployed it. So in addition to, straight right off the bat differences between Sandbox and production data, there can also be shifts in processes that happen generating the data. And the shifts in those processes can either be from independent changes happening in the real world or by model affected changes happening in the real world. So independent changes happening in the real world is pretty intuitive to understand, right? Let's say Netflix wants to do some kind of targeting with some particular movie, and it's targeted at some particular demographic, but the makeup of that demographic changes over time, right? The phenomena called mix shift. So when mix shift occurs, when the model is trained on outdated data, you're going to have inferior results because it's now going to be fed in data that isn't representative of the data that was fed into the machine learning model to begin with. So what's important to note about this is that these shifts can happen really, really slowly, right? In the case of the difference between Sandbox and production data, it can be a pretty dramatic and very obvious thing that happens, right away, that there's this like really glaring discrepancy between the Sandbox data and the production data. But with mix shift, these things can happen over the period of years, right? And as we think about how deeply machine learning is being embedded within real world applications, we can consider that it's possible that mix shift will affect and degrade the performance of machine learning models over decades, which is why it's important to monitor the performance of machine learning models, monitor the data coming into them, and monitor the predictions being made by them. But I think more interestingly than changes that are caused independently, so changes that are caused by like actual changes in demographics or mix shift, there's also changes that can occur because the model itself has been deployed, right? You think about lots of different types of machine learning models, and their purpose is to affect user behavior, right? In the case of a Netflix recommendation algorithm, it's to cause people to click and to watch a movie more. In the case of like a Facebook ad targeting algorithm, it's similarly to cause people to click more. So if we like zero in on the Facebook example, right? They have some amount of information about you from your demographic, from your like interests, whatever it might be, right? They start to zero in and they start presenting you with ads. And as you pull the lever of clicking certain ads and not other ads, you'll start to zoom in and Facebook will compile a more cohesive image of who you are. But at some point, you as a user might start to change, not just because of actual changes going on in your life, but because of changes that have been caused to you by that machine learning model. Like, let's say I was looking really, really hard for like a bike or something, right? And Facebook successfully managed to get me to click on a bike sale. And okay, they made their advertising revenue, and the bike merchant made the money from the sale. But I'm no longer interested in buying a bike, right? Because I own one now. So this model has affected the real world in such a way that it makes the model itself now redundant, right? Because I no longer need to purchase a bike. And what's interesting about this is when this happens on a mass scale, you'll see degradations in the performance, not just of the model targeting an individual, not just the model targeting Danny, but if the model has been successful in getting a lot of people to buy bikes, all of a sudden it doesn't make as much sense to target people with these bike advertisements. Now, this doesn't mean that machine learning is useless, right? Like trivially, it would still be useful to sell bike tires and bike pumps and all of these other things. But because of the changes that the model has made to the real world, the model itself is now somewhat redundant and not as useful as it used to be. So that's the second major cause of shifts in the underlying data. And the third way that that machine learning models can degrade over time is because of externalities affecting the system. And I know that this comes across as kind of like a catch-all, but what I really mean by this is externalities within the code base, right? So maybe you've got a data engineer who's controlling the data pipeline data getting fed into the machine learning model, and for whatever reason, they no longer have the tooling or the capability to produce some particular feature, right? And if you don't have good checks in place, it's possible that the newly filled in values of null for this column that was really important for the performance of your machine learning model, these newly filled in nulls are going to hugely degrade the performance of your machine learning model. And hopefully you have some kind of monitoring in place that shows you, oh, there's a bunch of nulls coming in. This might mean that my model will not be performing as well as it did. And you can see how this relates very, very closely to model explainability, right? If I know that this particular column is very important for the performance of my model, then I can know to monitor the incoming data for this particular column. And you can know that when I start to get a lot of nulls in that column, it's no longer satisfying for me to allow my machine learning model to remain in place without any kind of modifications. So at a high level, to answer the question of why do we want to do machine learning, the answer is quite simply because changes in the real world, as well as changes within the code base, can cause changes in how well the model performs, which can cause changes in the value that the model provides for the business, right? Ultimately, at the end of the day, when we're thinking about these deployed machine learning models, what we're most interested in is understanding how can I empower the business, how can I make money, save money, or decrease the amount of risk for my business. So this answers the why, which gets us into the meat of today's presentation, the how. And we're going to start off with a theoretical, just talking about the state of the industry for how. So before we dive into, a breakdown of what companies and projects are doing this, I wanted to pull out this visual of this graphic from Monitoring Machine Learning Models in Production, which is a really great blog post about exactly this topic, right? A lot of the inspiration for today's presentation came from this blog post, and I really highly recommend it to anybody who's looking to double click on a couple of components of the things that I've talked about today. But I think one of the most valuable things that Chris has done in this blog post is broken down monitoring systems into 3 components that every monitoring system needs to have. One is processing and storage. It needs to be able to accept and store incoming as well as historical data, right? So this means that you need some kind of a database, a data warehouse, a data lake, whatever it might be. You need something to store the data, to store those metrics that I was talking about earlier. But what's the point of sitting pretty with just some metrics in your back pocket? In order to make them useful, you want to be able to visualize those metrics, right? You want to be able to empower users to understand what's happening with my machine learning model, or in the general case of monitoring systems, understand what's going on in my system. And visualizations are a really great way for humans to understand what's going on with the system itself. And finally, this is a really useful component. I would say that it's at this point, it's basically table stakes. It isn't necessarily technically a key component, but practically, it's best to have an alerting feature built into any kind of monitoring system. And the reason for that is quite simple, right? You don't want to have to spend time looking at a dashboard every single day, if instead you can just respond to particular alerts coming in about changes happening that are affecting your machine learning model. So I found this breakdown into the 3 components to be super useful in understanding what types of things do we need to look for when we're looking at different types of monitoring systems. So I've broken down the tool set, the market space into 2 main categories, and then broken down those 2 categories into a number of different subcategories. So looking at the marketplace, there's 2 main categories. There's application-specific tools and general purpose tools. And by general purpose, I mean general purpose in the sense that they work for monitoring any kind of application, not just a machine learning model. But let's start off by talking about the application-specific tools. So one category of application-specific tools come from cloud or machine learning deployment providers. So what I'm thinking of when I talk about that is somebody like AWS SageMaker. Azure has a data drift. That's the name of the product, is data drift, built into their machine learning model deployment system. And some costs and some benefits to going with one of these options. So the benefit is if you're already using this deployment provider, this can be really powerful, right? Because it's fully integrated, one-stop shop, single pane of glass, all the buzzwords, right? And there's a really compelling use case around that. But there's a couple of downsides, right? As with any kind of cloud solution, there's the possibility of vendor lock-in, right? If you're using SageMaker for your deployment and you're using SageMaker for your monitoring, then when AWS starts jacking up your bill, it's kind of it's going to be a lot of work for you to move over to another option. So that's one disadvantage. Another disadvantage is that, and this is kind of a subjective opinion, and I don't think that this is always going to be the case, but from my examination of the tools that are currently available from these cloud machine learning deployment providers, they tend to be a little bit, I don't know what a polite word for this is, but basically it doesn't really seem like they care. Like, it's something that they slapped on at the last second because they knew that this is an important thing for machine learning engineers. Something like SageMaker, I think, is a really, really great tool for deployment, but there's just not that great of monitoring capabilities built into it. And like I said, I think this is something that can change over time, but as it is right now, there's some severe limitations to the ability to monitor models in SageMaker, in Azure, or really in any other ML deployment provider that I saw. Now, in addition to these ML deployment providers, where I see some of the best development happening in this space is actually from startups. There's some really cool startups out there who are doing model explainability, they're doing machine learning monitoring, and they're doing this in a very targeted and focused way that honestly is, leaps and bounds ahead of what AWS and Azure are doing in this space, because they're hyper-focused on solving this one particular issue, right? Some examples of this are Fiddler Labs. They focus primarily on explainability, but explainability and monitoring go hand in hand, so they also have a monitoring component. Superwise, which I think is a pun on supervise, presumably, has an ML monitoring component. So these are, generally like A or B round startups. They've got, pretty mature technologies that are really hyper-focused on solving the problem of monitoring ML models. Which brings me to the third component, which is open source projects. So unfortunately, there doesn't seem to be a lot of great work from open source projects in this space. And that's really disappointing because I'm a big believer in open source. Part of what makes Python so valuable isn't any kind of commercial usage around it. It's all of the work that members of the community have put into making Python packages, into making Python something interesting and useful for people to use. So the lack of open source projects in this space is really disappointing. A couple have come out. They're primarily being bankrolled by companies. So the degree to which they're truly bubbling up open source projects is, I think, questionable. So unfortunately, not a lot of cool open source stuff happening in this space. So those are the application-specific tools that are really focused primarily on ML modeling in particular. And they're really cool if the only thing you need to monitor is a machine learning model, but most of the time, right, a machine learning model exists in a larger space. It's part of a whole tool, a whole platform. So it's useful to look at the general purpose tools that you can use to monitor applications in general. And there's a number of different general purpose tools. And this is the part of the presentation that's going to be biased by my work at Imply, because I work for a commercial vendor who specializes in application performance monitoring tools. So I'm mostly going to be talking about what Imply can do, right? But in addition to Imply, there's some other vendors that also do application performance monitoring, and there's a whole list of trade-offs between different approaches to how you can do this. There's also a lot of really cool open source projects doing this, including Druid, which is what Imply is based on, which is a really powerful tool for slicing and dicing data, for backtracking to the three components in monitoring system. It provides a lot of the processing and storage, on top of which Imply provides a lot of visualization and alerting capabilities. So all of this to say that fortunately the open source space for general purpose tools is better developed than the application specific open source space. So I hope you guys are ready for my cheesy intro into the more practical part of today's presentation.
Okay.
But actually, before I get into that, if there's any questions, let's dive into those and answer any of those first, and then I'll give the whole like practical run through.
Yeah, I think there's a few questions. Greg Lee on the chat says, do you have any thoughts about prediction monitoring for subgroups? Any tips on robustness, sequencing algorithms biased towards certain races? So like, I guess Greg, you could jump in too, but my understanding is you're asking about monitoring subgroups of data or subgroups of your data of what your model is predicting on.
So, Greg, I think you might be muted, and I'd love to dive into and like understand this question a little bit better. So my understanding of it is that you're asking about like, in the circumstance that we have some protected group and we want to make sure that they're not being discriminated against, how can I monitor my model to make sure it's not discriminating against that protected group? Would you say that's a fair characterization of your question?
Greg left us.
Oh, well.
Do you have an answer to that question?
Yeah, I do. So I'll answer it nonetheless. So one of the really powerful things about the combination of monitoring and explainability is the ability to deal with like exactly these types of issues, right? Exactly these types of auditability of like legal limitations and compliance issues that are going to start to become more and more important in machine learning, right? There's a lot of spaces where machine learning can provide a lot of value that it simply hasn't been able to break into because there's a lot of regulations and compliance. So the financial services industry, healthcare, there's a lot of different areas where data could provide a lot of value, but right now there's limitations because of inability to comply with legal requirements. And the ability to explain why a model is making its predictions, the ability to like subset and understand, to dive deeper into the data, which is something that I'm really going to be focusing on in the practical component of today's conversation. The ability to dive deeper into the data is a really key component of being able to deal with those compliance and regulatory challenges that I think a lot more companies are going to be running into in the future. So to condense a very, very long answer, yeah, so you can monitor incoming data for particular subgroups and monitor the predictions for those subgroups and make sure that they fall within the legal requirements around discrimination in order to make sure that your model is being compliant. Before I move on, are there any other questions? I know that this was
a follow-up question about this discrimination stuff. So suppose that you train your model on a data, not blindly, whatever the data comes in, and then it turns out that by some metric at the end, you do discriminate some group. So you're going to define some metric, amount of money you received for something or whatever, and it's different than for everybody else. So if that's illegal, does that mean that you're going to have to train, that you're going to actually have to put in a special bias, special discrimination for that group into your training process so that the result in the end comes out even?
Yeah, and if you look at like the financial industry that is regulated around discriminations against predicted classes, you can see that they already do that even without using machine learning models when they're writing the business logic that generates effectively a very convoluted way of getting around to a prediction. They have to, if their original business logic flow results in what is considered to be discriminatory outcomes, they have to change that business logic flow in order to prevent that. And like anti-biasing is a whole can of worms to get into, which is like above and beyond the conversation around like explainability and monitoring, which can answer the question of like, am I discriminating, or like, is this model following legal or compliance regulations? The like, what do I do to make my model follow that is a whole nother can of worms that I would love to learn more about personally. I've really just been focusing on the monitoring component.
Okay, thank you. I think further investigation will be outside of the scope of this meeting.
I think so too. But I mean, it's a very interesting topic, and one that I think, like, as we as a data science machine learning community start to like figure out how to deal with the compliance and regulatory standards that are put in place, we'll be able to like disseminate the great work that we do a lot better. So I think this is like a really hot field and a really good topic for people to be working on, because it's going to be super impactful.
If I can add one comment, just Danny, maybe you've heard of this, but part of the Brexit campaign, they spotted some machine models that were fighting machine models in the form of bots from state actors were watching YouTube videos in a specific order in order to get people to have a to taunt the recommendation engine, essentially. So the attack was basically, I have so-and-so video that is of questionable and dubious veracity that I want people to watch. So I'm going to start with this popular video and then go through a bunch of videos and then somehow end up here. And if you attack the algorithm enough times, you can actually get the machine learning model to learn like it's doing the right thing, but you need to be able to monitor it to realize, oh, this is the pattern that it's starting to recognize. So yeah, there's a lot of question about getting more transparency on these models.
Yeah, so Ferris, I think that's a really great example of like a model that is kind of optimizing for the wrong thing, right? Because like YouTube is trying to optimize their model to get people to click on the next video. So if it sees a lot of people that click to this particular next video, then it's going to recommend you to do that because it wants you to stay on YouTube for as long as possible and watch as many ads as possible. This is what like the YouTube recommendation algorithm does, right? But as human beings and as, you know, like the Alphabet company, like they probably don't want YouTube to be doing this, right? Because it gets them in a lot of like PR trouble. It doesn't look good for them. And, you know, maybe they even, God forbid, care about human beings and like actually, you know, don't want these bad outcomes to occur. So this is an example where monitoring the incoming data, right? The data that's being fed to the machine learning model is hugely important. Because if you start to notice that, wow, it's kind of weird that there's like a bunch of IP addresses from Iran that keep watching these 3 videos in a row, like, why is this happening? You can start to answer the question of like, this might be an adversarial attack on my machine learning model. This is a great way for me to like, this is a great time for me to reevaluate how this model is being trained and see if I can exclude these bad actors from the model process. And on some extent, this has to be like a human in the loop process, right? Because we don't yet have the ability to like fully automate a machine learning when it's being targeted by an adversarial attack. So this is why like the monitoring component is so important, because a human being needs to be able to step in and say, although the predictions of my model are technically the right predictions for the model to be making based on what it's optimizing for, this is not in fact the best prediction for it to be making.
Excellent. Thanks for diving into that a little bit more. I didn't want to get off too much on a tangent, but that example always comes to me as between that one as like black box and that touches base on that, and maybe credit monitoring, like knowing, hey, what's my credit score? Like we don't know the algorithm really that determines our credit score. So we yeah. So I'll stop talking about this.
Hey, Danny, to bring us maybe back around on topic. So you seem to, in the flow of your talk, be moving on to implied as a tool. I'm interested on the open source projects. I know that ML Run as well as Kubeflow metadata are 2 open source tools that are doing metrics tracking, model performance tracking, and some of that, like, and then using something like Prometheus or Grafana to display those metrics. How do you feel those tools are? And maybe as you go through implied, comparing and contrasting, like, what is implied doing better than those?
Sure. Yeah, I can definitely touch to some extent on that. I don't want to like turn this into an imply sales session. Like I want to like, you know, use the tool that I have in front of me, but I don't want to like get too deep into why imply is great. I spend all day doing that already. So just from like a high level, I think In general, there's like issues with deploying open source projects that, generally require a ton of overhead in terms of engineering time to maintain, even if it's like a very well-developed project, which, to be honest, like some of these, like Kubeflow is quite well developed, but there's components that I think are less well worked on. As to the, I don't remember what you said the other open source project that you were talking about was. I haven't
ML Run. It falls more into the category of like vendor supported open source. It's made by, that one's, I think it's made by Databricks.
Gotcha. Yeah. So there's, I think there's like issues with like dealing with an open source project that's basically like a way of a company just trying to get someone else to work on their stuff for them. But yeah, I haven't personally used it, so I don't feel confident talking to the like differences and the advantages of imply for that particular situation. I think like instead of turning it into like an imply sales thing, what when we get to the practical component, what I'm going to try to do is focus on like, what am I doing? How am I doing it? And like, you can probably do the things that I'm going to do with imply with other tools as well.
Okay, yeah, I'm interested to contrast kind of what I know about those other tools with what your tool is. I mean, this whole MLOps field, all of the tools are really new and being actively developed, and so like it's an exciting space to be in.
Yeah, it absolutely is. Okay, if there aren't any other questions, I'll give it another couple of seconds, but otherwise I'll jump into like kind of walking you through this hypothetical example that I've developed. Okay, cool. We can circle back at the end of the practical component as well to see if there's anything else that people wanted to know about. So just as a little bit of warning, this is the first time that I've presented this outside of my shower. So I haven't tested this component in real time. And earlier today, I was having some trouble with the Kafka instance that I stood up for this. So I'm flying by the seat of my pants here, and hopefully everything works as intended. So we're going to start off by explaining kind of the high level situation. You work as a data scientist / machine learning engineer for a workspace company that wants to be able to predict whether or not a person is in a room. And they've got access to certain information about the room, like the temperature of the room, the humidity of the room, the amount of light going into the room, the amount of carbon dioxide in it, and the humidity ratio. And what they want to be able to do is predict, like, is there anybody in this room? And if there is someone, then, I don't know, we'll run the AC, or like we'll have the lights on. If not, then maybe we'll put the lights on a timer and, get the AC ready to shut off, right? And what this company does is it's going to collect all of this IoT data, and then it's going to hire some intern to sit there and watch the camera feed and tick off, every minute there is a person in this room or there's not a person in this room. And this process of this intern doing this and this IoT data creates this training data set that you see in front of you, which has a date, it's actually a timestamp, temperature, humidity, light, carbon dioxide, humidity ratio, and occupancy. Now I'm going to go through the process of training like a super simple machine learning model. Please do not take this as gospel about how you should train a machine learning model. This is like very, very much me trying to minimize the amount of code that I had to write for this presentation. So I have my training data that was sitting in a CSV. I've read it in. Now it's in a pandas data frame. I'm going to create my my target variable, which is train Y. I'm going to have my feature matrix, which is train X, by dropping both the occupancy and the date, because I'm not interested in trying to make a time series prediction here. And if we take a look at the feature matrix now, it only contains the data that we're going to be using to make predictions, the independent variables. So from scikit-learn, I'm going to import a random forest classifier. I'm going to train it on my training data, and voila, that's it. We did machine learning. Now we can go home, right? Now, like, let's do some work here. So the next step is we want to have some testing data in order to understand how well will my model perform on novel data. Hopefully my testing data is representative of production data, but fortunately we're going to have a monitoring system. So even if the testing data isn't representative of production data, we'll find out very quickly if there's some weird anomalies going on. So if we take a look at the testing data, it looks like it's basically of the same style as the training data. We can go through the similar process of dropping some columns from it, and then we can score our model, and we get 96% accuracy. Again, please do not take the way that I'm doing this as gospel. Accuracy is a very bad way of testing how good a machine learning model is. But again, for the sake of today's presentation, I want to keep things as simple as possible. So I've done my scoring, and my model looks good. It looks like people are predicted to be in the room about a third of the time, which just kind of checks out to me in terms of how I think about how often people are going to be in a room at a workstation. So I've trained my model. I'm going to save this model object, and now it'll be referenceable by my production system, which, just like I said, please don't take the way that I trained this model to be gospel. Similarly, don't take the way that I productionize this model to be gospel, because I'm just going to read it in another Python notebook, and that is not a good way to productionize machine learning models. So I've saved my model, and now I'm going to feed my data into a Kafka instance by running through the whole data set, making predictions along the way, seeing how long it takes to make every single prediction, and bringing all of this data into Kafka, where it's then going to be read into imply. And during the intros in today's presentation, I actually jumped the gun on this and have already imported my data into Kafka and into imply. So we can take a look at it with the imply interface over here. So what we've got here is a line chart that represents the number of events broken down, bucketed into every hour for the time period from February 2nd to February 18th, which is more or less the time period that we're looking at here, right? So we can see that there's about 60 events every hour. It might be off by one because of the way that minutes are handled in the original data set. It looks like I have some gaps in my data. Maybe my intern got lazy. Maybe my camera stopped working, whatever. We've got some gaps in the data, but overall, it looks like I've got a pretty complete data set. We can take a look at the dimensions that we have. We've got carbon dioxide, humidity, the humidity ratio, all of that stuff, right? Now, if I'm interested in understanding, what's going on with my data, the data that I use to both train and test my model, I can take a look at some different variables other than just the number of events that have occurred. Let's say I want to know the average occupancy. So I want to know for every hour, about how much of the time were people there. So, some hours occupancy, the average occupancy is 1, which means that the room was fully occupied for that whole hour. Sometimes it's 0, which means that there was nobody in the room, right, at 10 to 11 p.m. This makes sense. If we're at a WeWork, there's not going to be someone there unless there's a party going on, which I guess there wasn't here. There's a dip from 1 to 2 p.m. where the ratio is 0.62. So people were there about 2/3 of the time. Maybe somebody, people stepped out of the room for lunch for 20 minutes or whatever. So this is some interesting high-level information to know, about how often are people coming into the room. I also can look at the average amount of light coming into the room. This might become an important variable later. And we can take a look at our average prediction, which looks very similar to our average occupancy because, as you guys will remember, my machine learning model performed very, very well. So it more or less should look similar. In fact, I can compare the two of them. I can compare the two of them by doing multi-selection and say, okay, here's my average prediction and here's my average occupancy. And it looks like they more or less follow the same patterns and trends. Okay, this is pretty cool. I feel satisfied. I'm ready to put my model in production, by which I mean put it in a different Jupyter notebook. So I've got my production data. I'm going to look at February 16th, which is the next day that I have available. Because I actually had the full data set, I secretly know what the occupancy is, but I'm going to drop the occupancy column because I've deployed my model and I don't want to keep paying my intern to rate whether there's a person in this room or not. So I've gotten my data ready. I'm going to load in this machine learning model that I trained earlier. And now I'm going to go through every row in the data set and I'm going to make a prediction about whether there was a person in the room or not. And I'm going to send all of this data through Kafka. So we're going to run through this loop for all of the data. and it's writing to the same Kafka topic that I was looking at earlier. Let's make sure that we have this set to update.
Sorry, so just a clarification here. The way that you get metrics into imply is through Kafka?
Correct. So there's a number of different ways to feed metrics into imply, and maybe it would actually be helpful to walk through what that process looks like. So if I wanted to load data, I start off by selecting, is it coming from like Kafka or Kinesis? Is it coming from static data in like an object store? Am I, looking at a HDFS, something like that? So in this case, we're looking at Kafka. I specify the Bootstrap server and the topic. I need to parse the data and parse the time for it. And then, I go through a couple of different settings, tweak some knobs, and submit this ingestion spec, which allows me to ingest data, in this case, in real time with Kafka. So what you're looking at here is the open source Druid data loader, which brings me back to what I was talking about earlier in terms of breaking down the three different components of a monitoring system, right? In the case of imply, what we were looking at before in this data visualization view was a visualization, right? This data cube, and this is something proprietary for imply. But actually what you're seeing here is just the open source Druid data loader. So once we've loaded in this data, it becomes available in Pivot, this visualization interface, which allows us to do stuff like build the visualization that we were looking at earlier. And we can rebuild that visualization really easily. We just want to look at the time dimension. We're breaking it down by hour. We want to look from February 2nd to February 18th. We want to bucket it by the hour, and we want to look at like the average occupancy or something. Okay, so we're looking at the average occupancy, and I am indeed flying by the seat of my pants because, this is interesting. So I'm looking at average occupancy. I should be looking at the average number of predictions. Okay, this is weird, right? Like, just looking at this like a normal human being, it looks like on any regular day, we expect at least at some point that there's going to be full occupancy or like a full hour of occupancy in my room. But it looks like on this production data that I've just brought in, for some reason, we don't seem to have a prediction that there's as many people in the room. And what this is causing in the real world is consternation, right? Because people are walking into rooms expecting there to be air conditioning and lights on, but instead they walk into a dark and boiling hot room because our model is predicting that there won't be anybody there when in fact there is somebody in this room. So now I, as a machine learning engineer / data scientist, am getting a lot of trouble from my boss, right? And he's asking, Danny, you deployed this model. What the heck is going on? Like, why is this thing underperforming? And I can look at this dashboard that I've already created and say, okay, like, yeah, my model is performing really, really weirdly. Let's look at some other information. Like, do I have the same number of events coming in every day? Yeah, it looks like I'm bringing in all the data that I would expect to bring in. But this is weird. The average amount of light coming into the room appears to be lower. And the average amount of light was a really strong predictor in my model of whether there was going to be somebody in the room or not, right? And the reason for this is kind of tricky. It's because if there's no light coming into the room, that means it's dark outside. If it's dark outside, that means it's nighttime. If it's nighttime, then there's not going to be anybody in the building and therefore not going to be anybody in the room. But what if there's a cloudy day? What if somebody covered up the windows? There's a million different reasons why it might be dark in a room. And just because in my training data, it was dark in the room only when it was nighttime, now that I've actually got my production data, it looks like it's dark in the room, even at hours that we would expect people to be there. But let's validate this hypothesis by enlisting our trusty intern again. So now we're on February 17th, it's the next day. We've got more production data coming in. This time we've paid our intern to do the same thing they were doing before. We no longer have to drop this occupancy column. We can import our classifier again. and run through this process of adding in data. And you'll be able to see that data gets brought in real time. With every 5 seconds, there's going to be an update to bring in new data as soon as it gets read to Kafka or written to Kafka. There we go. It's taking a little bit of time to process on the Druid end. Let's go back to our data loader and just make sure that the data is coming in properly. As I mentioned, I'm kind of flying by the seat of my pants here, so hopefully everything's still running okay. Looks like it's still running fine. Okay, it looks like my Kafka cluster has finally decided not to cooperate with me. The point being, we've been able to look at the data and see that we can see a change in the average amount of light coming in. And we can say, okay, now it is populated. So it's again a cloudy day, but if we look at the average occupancy, we can see that even though the day was cloudy, there were still people coming in, just like we would expect them to, right? So what this indicates to us is it's time to retrain our model, right? We've got a problem with our model where it overfit to the variable about the amount of light, when in reality, the amount of light isn't that strong of a predictor, specifically during daytime, right? During daytime, whether there's a large amount of light or a small amount of light doesn't matter. What matters is whether it's daytime or not daytime. So this is a situation where we were able to monitor a model as it was making its predictions, right? We were feeding in data in real time from this Python process into Kafka, from Kafka into Druid, and then from Druid into Imply, into this data visualization. So
hey, Danny?
we were, yeah.
On that Kafka instance, are you running that locally, or is there a Kafka instance that Imply provides that you're sending that data to?
From a high level deployment, what I've done in this particular situation is I've got one instance running this Jupyter notebook. This is running in AWS. I've got one instance running Kafka, and I've got one instance running Imply Druid. So Imply doesn't provide Kafka, and the reason for that is because you can use a number of different streaming pipelines for integrating with Imply. You can use Kinesis, Kafka, Azure Event Hub, or you can use a number of different static sources as well.
But Imply does then set up the Druid instance to gather all the metrics and visualize them.
Correct. Yeah, exactly. So it stands up a Druid cluster with a lot of improvements on top of the open source. And then it also provides this visualization as well as an alerting framework, which I didn't really incorporate into today's presentation, but fundamentally could have worked really, really well for the issue that we were trying to handle, right? If we look at the room occupancy data cube, if we look at the room occupancy data cube, we can see that we can have it check every hour for the past hour and look at the, let's say, the average prediction. And if the average prediction was 100 time was, let's say, like lower than 50% change from the same time 1 week back, then we would receive a notification via email or via Slack. So what's really powerful and what's really interesting about this is that instead of having to sit there and look at that visualization that I had made earlier, I can just set up this alert to deliver a notification to me whenever my model seems to be performing weirdly, whenever there's changes in the incoming data, whatever it might be. So the ability to monitor stuff like how long did it take my model to make its prediction whether my model is predicting less or more occupancy than it was before, and whether there's any changes to the incoming data is all captured with the alerting feature. So, are there any other questions around like how you can use imply to do this kind of monitoring, around different types of tools, around monitoring from a high level perspective?
I do have some questions. So some of the things, so with what you said, implied is really providing a managed Druid instance, this UI interface and alerts. The UI interface and alerts, I feel like those, Grafana as an open source tool and also Graphite both provide like similar visualizations against some sort of data source and alerting built into them. What do you think about those tools?
So I think Grafana is a really powerful tool. I would say that there's a lot of reasons for the very specific use case that we're talking about with integrating with Druid, which is a really powerful OLAP, database analytics platform. One is that Grafana, just like the majority of other data visualization technologies, actually pushes down queries rather than generating every data set for the visualization with every time the user interacts. What it does is it pushes down a query to collect a subset of the data from the database and then brings it into Grafana. And what that means is that there's always going to be a trade-off, right? Where either you're going to be dealing with a subset of the data, right, which isn't super useful, especially these days when you can access all of the data, or conversely, you're going to be running out of memory a lot of the time, right? Because like simply there's a limit to the amount of memory that you can store on a single machine. So what's really powerful about Pivot compared to basically any other data visualization option out there right now is that Pivot integrates directly with the underlying database, with Druid in this situation. There's a lot of other reasons for why somebody might want to select imply on top, rather than or in addition to an open source stack. We talk about it as managed Druid. It's actually above and beyond that. It's not just a managed Druid instance. There's improvements on top of the open source around performance, huge improvements in terms of like the speed, the amount of data, the types of interactions that you can have with our data, like really big improvements to the joins feature above open source Druid. In terms of like deployment and monitoring of the Druid application itself, just like we could monitor our machine learning model in real time, we can also monitor how is our Druid cluster performing because of built-in monitoring with the implied platform. There's the ability to like seamlessly upgrade or downgrade, to change versions, to upscale and downscale the cluster just through like interacting and clicking with it. There's a lot of different and really powerful tools for enterprises who are interested in having multiple groups of users, role-based access control, the ability to like integrate this with your own product and deploy it directly to your customer. So I want to avoid getting like too deep into a selling situation. But at a high level, there's a lot of reasons why somebody might prefer a tool like Imply. And if you're interested in learning more, I'm really happy to have a more in-depth conversation around like Imply versus other types of tools, maybe during like regular working hours. Actually, one of the other people on this call, Holden Ackerman, is an account executive that I work with really closely, and we'd both be really happy to sit down with anybody who's interested and have a conversation about what Imply can do for you. But I just don't want to like spend too much more time without knowing the particular use case that would be interesting to someone.
Right. Well, and kind of like I bring it up a little bit, just seeing what the landscape of tools are out there. Now that you've kind of given an idea of what Implied does, just thinking about other monitoring solutions, Grafana and Graphite have both like served me well in the past for this type of metrics monitoring, even alerting where you want to trigger on some sort of average over time, or some other metric, maybe in comparison where you have two metrics that pass some threshold together, like those sorts of things. I've seen those both be good open source tools for that type of metrics monitoring.
Yeah, and you know, like all of that is definitely doable with an imply. There's even the ability to integrate with EGADS, which is an anomaly detection system, open sourced by Yahoo. So you know, even more advanced, like building machine learning basically into the anomaly detection, which is super useful for unpredictable changes in the data, or when you don't want to set up these like simple business logic rules. So that kind of like advanced anomaly detection can be really powerful as well. I think like taking a step back, what separates imply from something like Grafana is that we're not just the visualization layer or like just the alerting layer. And a lot of it really does come down to the open source project Druid, right? Apache Druid is a really, really powerful tool and technology created by the co-founders of Imply before they started Imply. And they went out and they produced this open source project that got a lot of traction with companies like Netflix, like Hulu, like Airbnb. And they saw that there was a real demand for the power of this like interactive OLAP engine to provide for what we call hot data analytics. So beyond simply monitoring, what Imply does really well is allow you to interact with the data in real time. You know, like you saw, we've got data being streamed in real time, and you can just drag and drop and, you know, modify the visualization to really have a conversation with the data and understand, you know, like what's going on in the real world to answer these questions. So I don't say any of this to like bash Grafana as a tool, but to some extent, like as an open source technology, when it's like really great for developers to play around with and use, but for like a big enterprise, really for like any size enterprise, the support that comes with a managed service like Imply has proven to be invaluable to a lot of our customers.
I have another question that's not just like this visualization, but on the topic of machine learning monitoring. One of the components of that tool, open source tools like the ML Run and Kubeflow metadata tracking provide is artifact tracking, particularly around graphs. So say I train a model or I have a prediction on a model and I have some visualization, maybe an ROC curve. These other metadata tools actually track, like have a way to track those images and associate them with given spots in time, you know, given runs, given prediction times. What do you think about like artifacts as metadata tracking for as like monitoring?
Yeah, so I think, you know, like going back to the different types of tools, I think there's a lot of really cool work being done in this like application specific space, right? Like, and ultimately, you know, Imply is never going to be the best tool for specifically monitoring machine learning models because we don't have explainability features built in. Because ultimately, Imply is solving a larger problem, right? It's providing like a single interface and a single pane of glass that allows you to monitor not just the machine learning model itself, but other components of the pipeline, other components of the platform, as well as being able to do more than just monitoring, right? Because it empowers data-driven applications. So like if you want to embed some visualization for your users of your website to interact with, you can use Imply for that. If you want to like monitor how, or if you want to do analytics on how people are using your product in order to improve the product itself, you can do that. So like ultimately, you know, I don't have like a feature matrix of like Imply, other people, like application specific people, and zeroing in on the example that you brought up of like comparing something like the ROC curve. My like first impression is like, why would you want to track the image instead of like the underlying metrics that are used to generate the image, right? Like the ROC curve is created by plotting a number of different metrics. So if you monitor those metrics themselves, that gives you the same information without like the overhead of storing an image, which is like a more expensive than a single number to store.
Another example would be, I mean, the ROC curve is essentially a histogram. So if you had several models, or like if you had some, like your model is actually an ensemble and you're comparing across them, or other histograms of your data that you want to not store like every data point, you know, like the histogram's a nice way to actually compress that data. And an image is actually a fairly nice way to score that, as opposed to single metrics for like that could be averaged or plotted. Visualization tool.
I think I see what you're saying. Yeah, like I can definitely see a lot of value from being able to like make those comparisons. I would still push back on the idea that like a visualization is an efficient way to store data. I think a visualization is an efficient way to share data, to like explain data. But like fundamentally, you know, you can save the bin size and the amount in each bin, and that'll save the same amount of information, which is like hugely compressed compared to like saving, you know, pixel by pixel or even a compressed version of an image. But this is really like getting down into some weeds. Like coming back up out of it, I think the main takeaway that I want to leave you with, if you're like really interested in comparing Imply versus other platforms, is that I don't think that Imply is the best tool for ML monitoring, but I do think that it's probably the best tool for solving these more general types of problems of like having a single tool that can do monitoring, product analytics, all of these different, you know, IoT analysis and tracking. We have so many different use cases that so many different customers use us for. In the Rockies in particular, there's a really big retailer. Holden, are we allowed to talk about the person we interact with in the Rockies?
Yeah.
Was that a yes?
Yeah.
Yeah, okay, so we work with Overstock, and they use us for like a ton of different use cases, including monitoring, you know, like over Black Friday and Cyber Monday, how their servers are doing. So yeah, there's a lot of different applications beyond just the ML monitoring. Machine learning is just something that I personally am very interested in, and I saw like a cool application for Imply within that.
Yeah, I would also add too, I mean, one of the big trends I've noticed across, you know, dozens of our customers, at least that have data scientists that are, you know, using it in a ML monitoring capacity is also, you know, you want to see if the data is flowing in that's feeding your models correctly. If you're getting quality data, if you can find that in real time and get alerted on that, or, you know, it's missing, then you aren't getting fed garbage data and you're not going to have a garbage model, and you don't have to go through that whole debugging cycle, and you can kind of nip, you know, it in the head. In feature discovery, you know, when you're building new models and you're trying to see if things are just anomalies or if they're really important and they're becoming, you know, interesting trends, those are also, you know, various areas that just getting that data in, you know, this very interactive and very fast state, whether again you use Imply or you just use the really open source kind of Lambda analytics architecture, if you will, definitely is a really big area for you know, data science. Sorry, not a question, statement. I guess, Danny, one thing, if you had to give some suggestions to folks, you know, here on the call that are just getting started with productionizing their machine learning models, and, you know, what some best practices might be to consider, you know, and how you would really want to get started when you are using these types of tools, what would you recommend to some folks?
Watching my talk from last year. Aside from that, I think, like I mentioned, CD for ML is like a really, really great like thought piece, just talking at a really high level around like best practices. Martin Fowler like revolutionized ops for software engineering, and I think there's a lot of revolutionizing that needs to happen for data scientists and machine learning engineers for how we think about deploying models. Beyond that, like talking to me is a really great option too. I have spent a lot of time in this space and spent a lot of time reading, practicing, talking to practitioners, and have like kind of a high level perspective on, you know, how are people productionizing their machine learning models? What do they look like when they get into production? What are challenges, both technical as well as business challenges, that a lot of data scientists and machine learning engineers face when they actually get models into production? So I'm always really happy to chat data science, be it like in the context of Imply or just, you know, connecting and walking through, you know, whatever's on your mind. So feel free to reach out to me on LinkedIn. or over email, which I think will probably be provided in the meetup. Right, Forrest? Forrest is nodding.
I'm like talking to myself. Yes, we will. Wherever you paste to us, we'll put it on the group, and if you have a GitHub repo, we'll fork it to the SLCPython one. So,
any other questions as we wrap up the practical component of today's presentation? Cool. Okay. Well, if anybody does have any other questions that pop up, Dylan, if you or anybody else wants to talk more about Imply again, please don't hesitate to reach out. There's a lot of really interesting stuff that we do over at Imply that we're always really happy to talk about. Today's presentation has been mostly focused on like general education around machine learning monitoring, rather than like education around what Imply does. But if you're interested in hearing more about what Imply does, please don't hesitate to reach out about it. I'm gonna stop sharing and hand the mic back to Ferris.
Thanks again, Danny. That was a great presentation. Usually people clap, but if you want to clap, you can use the reaction button down on your Zoom, and yeah, look, lots of people clapping. Awesome. Yay, virtual applause. All right. And as we wrap up here, we'll get to the last part. So our next meetup will be, let's see, it will be on the 6th, I believe, of January of 2021. Yep. Joe?
Yeah.
Any more details on that?
Actually, it's actually gonna be a nice follow-on to this. It's how to not fail with machine learning in production. So surprisingly, this is a topic now that people are finally doing machine learning for real. So I'd say expect more of these types of talks going into 2021. Starting with Tyler Folkman, who's got a lot of experience in this area. So
awesome. And that hasn't been posted yet, but it will be soon.
Yeah, I'm gonna post it tomorrow, so y'all better register.
Awesome. Yes. Excellent.
Yeah.
And yeah, so make sure if you have not yet already, and you're already on this call right now, then you're eligible to join.
Your audio's cracking up there, Ferris.
Oh, is it? Oh dear.
Or mine is, I don't know.
Well, I won't be much longer. Now I forgot what, oh yes. Our next meetup, covered that. Yes, okay, so go ahead, go to the Slack invite right here, click on that if you haven't, and make sure that you are in the correct group, which is this one. Nope, this one, which is 2020-12-02, and I posted that in general. Only reason being is what I can do now is type in who with a slash, and now I have a group of people. Oh, look, Lazy Mutt just joined. So I'm going to take this string, and that'll be our raffle. So while people are adding that and I'm talking, I'm going to go and grab one of our exemplar prizes. We'll be giving out the Pi badges or Pi portals today. I think I have one more Pi portal, so I think this is it. So I'm going to turn off my virtual background so people can actually see this. Downstairs, it's boring down here, so I was at the, there we go. Okay, so there's a Pi portal. It's pretty nifty. It looks like just a screen, which it is. It's a touch screen, but it is a system on a chip. And what's really cool about this is an entire computer that runs Python. You plug it in, it has Wi-Fi, it has an SD card slot, it has an accelerometer and speaker outputs, and what else? I2C inputs. So if you wanted to do anything with like machine learning and temperature, you could probably, oh, you know what you could do maybe, because this is a touch screen. If you wanted to do a startup is, and Dylan's going to stop me before I finish, but if you want to do a startup, you could put this next to like a conference room and have it like ping a server and maybe integrate it with like Google Calendar or something, and then you could use it to reserve a room.
You could do like occupancy tracking.
Yeah, you could do occupancy tracking with, no. You could do what you want. This is on the edge. And the joke that Dylan and I are making is we both, and as did Joe, worked at a company called Team that did pretty much just that.
So For people that know about Team or Verdigris right now, I swear I did not tell Danny to get this talk. He gave this on his own volition. It was very creepy as we started. I think as Ferris and Dylan and I were watching the content, like, dear God, that's exactly what we all worked on for years.
Yeah, when you mentioned meetup WeWork occupancy, I like vomited a little in my mouth. But that's neither here or there.
Just Venmo Ferris some money for a beer or something.
Yeah.
So.
Not to disparage my old employer, ever. No. Anyway, this is from Adafruit. The other one that we got is a Pi badge. This one's a lot more clicky with actual little buttons. It's not a touch screen, but it does come with 5 RGB lights over here that you can also code. This one also has far more inputs available. And again, it just runs Python. So I'm going to give away 2 prizes, and it's either going to be 2 of these, or 1 of these and 1 of those, or 2 of those. So Pi Portal and Pi Badge. So make sure you are on the Slack. And looks like we have 3 more people who joined. And this is the last call. Oops. Who? All right. So just going to copy this text string. And I'll put it right here. And what do people think of this? This is my pair programming. Like, this is pretty much our code review right here. Does it look good? Yeah, getting some thumbs up maybe.
+1.
+1 from Matt, awesome. So if this gets screwed up, Matt was auditor, so. Let's see, and I think I can just hit run. I thought I had a launch JSON. I'm just gonna do this the correct way. Invalid syntax. Everybody know what went wrong here? There we go. I still have Python 2 mapped for historic reasons. Ollie, you are the first winner.
Yay, thank you.
Please DM me your address, and that is also my to-do list, so awesome. And let's draw one more time. Drum roll, boom. Drew, welcome to the group. You won a prize.
Sweet, thank you.
Yeah. Please ping me on Slack with your address, and I will ship those out to you pronto. And once again, our next meetup is on the 3rd. What I like to do in real life is usually grab a beer with you guys, but because everything's virtual, what I'll do instead is I'll stop the recording. So goodbye, online people.